Hello and welcome to this final video in this series on the sine and the cosine rule. And what we're going to do is we're going to look at using what we've learned in the previous videos in this series to solve some questions to do with bearings. Well, we are at the link works. Let's just skip ahead to it. Here we go. Okay, so often with these kind of questions you get text instead of diagram, so it's quite a nice idea to draw yourself a sketch. So a plane leaves an airport and flies on a bearing of 290 degrees for 120 kilometers. So let's just have a point. This can be the airport. So a bearing of 290, so that is going to be off in this direction somewhere, and it's going to go 120 kilometers in that direction. It then changes direction and flies on a bearing of 040 degrees. So that might be up here somewhere. I'm just going for 50 kilometers, so I'm going to do a smaller line, shorter line. And then it says calculate the bearing and distance that the plane now is from the airport. Okay, so if I join that back up to the airport, and I'm going to draw in some north lines, because we always want to go from north when we're looking at bearings questions. Okay, so calculate the bearing and distance the plane now is from the airport. So I've got two parts of this. I've got the bearing and I've got the distance. So I've marked on the lengths in the question. Now I'm going to go back and I'm going to mark on the angles. So bearing of 290. Now bearing is always measured clockwise from north. So this angle here is my 290. And for the second one, clockwise from north is there, and that gives me 40. Now I'm not going to put the 0 in front because I'm interested in the angle rather than the bearing for now. And the 0 is just an extra complication really. Right, so what can I work out from here? Well, let's have a think about this. Okay, so I've got two lengths of the triangle. I need to find another one. Now there's probably a lot of things I can do here to work out the angle I'm missing, because I could use alternate angles, I could use corresponding angles, I could use co-interior angles, and that's because all these north lines are parallel to one another, because obviously they're all in the same direction, which is north. So what should I go for here? I might extend this north line down. So this 290, I'm just going to scribble that out because I'm just going to replace it with an angle of 180 degrees, which is going from north to south. And then an angle of 110 degrees, which is from south around, because 180 plus 110 gives me that 290. So that's 110. And then I'm going to use alternate angles. I'm just going to change colour for a moment. That's not how to do that. Okay, so this purple angle and this purple angle, that is, those angles are alternate. So they are equal to each other because we know that alternate angles are equal, which means, I'll stick in purple then. So this angle here is then 110. Subtract 40, which is 70. So now I've got an angle inside my triangle. That may be enough for me to go on, well, certainly for now, because it's also handily opposite the side I need to find for the distance. So if I use this as lowercase a, I've now got this as capital A, and then I've got a B and a C, and off I go with the cosine rule. So let's just write out the cosine rule. A squared is B squared plus C squared minus 2BC cos A. So A squared equals 50 squared plus 120 squared minus 2 times 50 times 120 cos 70. So then I'm going to work out a squared. So 50 squared plus 120 squared minus 2 times 50 times 120 cos 70 gives me a massive number for the moment. I'm going to square root that, and I'm going to make sure I'm using square root of the answer function on my calculator, so I keep as much accuracy as I can. And I'm also going to store that in my calculator using the memory function, because I may well need that later. I haven't decided if I need it yet, but it's worth storing it, so I've got that exact value. But what I have done is calculated my distance being 113.118 kilometres. Alright, so what about the distance? No, done that. What about the bearing then? So the bearing is the 290 degrees plus this extra angle I've marked on here, because then that's going to be from north around to the line which is going up towards where the plane is. So need to find that angle there. So let's finish up labelling my triangle. So that's getting a bit crowded down here, but that angle is capital B, this one up here is capital C. So I should be good to go with the sine rule. Or the cosine rule actually, because I now know all three lengths, so I could go with the sine rule. Or I could go with the, sine or cosine. Let's go sine just for a bit of a change. So I will need to use sine B over B equals sine A over A. So then I've got sine B over 50 equals sine 70 over 113.118 and so on. And this is why it is important that we stored it in the calculator, because we're going to need to use that exact value when we come to type this in. In fact, we're going to need to do arc sine as well. I might just do this all in one go. So I stored it in memory A on my calculator, so I'm just going to type in A in place of 113.118, and then that's going to recall that from that memory. That gives me 21.541, so on and so on and so on. So that's this angle inside this triangle. So the bearing is the 290 plus that, which gives me my final bearing of 3141. One decimal place would be alright, I think, 0.5 degrees. So there we go. So they tend to be really quite tricky, these ones with bearings. You probably wouldn't get a distance and a bearing to work out in the same question, but there we go. So we've got here a mixture of angle rules to do with parallel lines, which is from such much lower level work, and then in this particular example we've used both the cosine and the sine rule too. Alright, so some for you to have a go at now. Here you are, and here are the answers.